Alright class, let's look into chapter 2.4, solutions of linear inequalities. So a linear inequality, or first degree inequality, the variable x is an inequality that can be written in the form ax plus b is greater than 0, where a is not equal to 0, and the inequality symbol can be greater than or equal to, less than, or less than and equal to. So, in example 1, we have 3x minus a third is less than or equal to negative 4 plus x. So, let's go about solving this example. So, we'll use blue. Blue works fine. Alright, so what we're going to do here is simply solve it as if it was a regular linear equation with an equal sign, except the only difference here is we have an inequality. So, let's just solve for x. Now, we can use the little thing if you don't like to deal with fractions. We can do the little trick where we multiply by the denominator on everything to get rid of that fraction. That's perfectly fine. So that what we're looking at, we distribute this 3 here, we get 9x. Now 3 times negative a third is negative 1, so minus 1 is less than or equal to, and 3 times negative 4 is negative 12, and 3 times x is 3x. Okay, so now all we got to do is get the x's together and get the constants together, and we'll be good to go. So I'm going to subtract off 3x to start with. So that what I get here is 6x minus 1 is less than or equal to negative 12. I need to add that 1 to that 12, so that what I'm looking at next is 6x is less than or equal to negative 11, and obviously if you divide by 6 you get x is less than or equal to negative 11 over 6. So that would be your answer. Okay, and if you didn't use the little trick here and multiply by 3 to get rid of this fraction, you still should have come up with the answer x is less than or equal to negative 6. Alright, let's move on to example 2. Example 2 says for an electronic reading device, the weekly revenue and weekly cost in dollars are given by R of x equals 400x and C of x equals 200x plus 1600, respectively, where x is the number of units produced and sold. For what levels of production will a profit result? Okay, so you got to know a little bit here about the context of this question. Okay, revenue is how much you make a week. Weekly cost is how much it costs you to make that. Okay, so in order to result in a profit, 400x needs to be greater than or equal to, not even really equal to. If you're equal to, you break even, you're not making a profit. So just strictly greater than 200x plus 1600. Sorry, 16,000. Oh. Alright, so essentially all we've done here, I'll write the margins, is in order to result in a profit, we need our revenue R of x to be greater than our cost C of x. Okay, so that's all we've done here. Revenue was 400x, cost was 200x plus 16,000. So let's just solve for x here. So I'm going to subtract this 200x over. I'm going to do that. 400 minus 200x, so it winds up to be 200x is greater than 16,000. Alright, we're obviously going to divide 16,000 by that 200. so that what we get is x is greater than, and you can check me on this, 1600 divided by, sorry, 16,000. I don't know why I keep saying 1600. 16,000 divided by 200 should give you 80. So x here should be greater than 80. So we need to produce more than 80 units in order to result in a profit. So if you just make 80 units, you're not making a profit yet. You have to actually make more than 80 units. So here's where you have to read into the context of the problem here. If you're making something, you can't make a half of something and still make money. At least I wouldn't think you would be able to. Can't make half of an iPhone and make money, I wouldn't think. So if you're going to make a unit to make money, looks like you would need 81 or more units in order to actually make a profit for the week. Alright, moving on to double inequalities. So an example of a double inequality looks like this. Very simple one. 0.479 is less than or equal to h is less than or equal to 1. Okay, a double inequality simply has an inequality on the left and also has an inequality on the right. So a student takes or has taken 4 tests with grades of 90, 88, 93, and 85. If 5 tests count the same, what must she make on the 5th test to make a B? So we calculate her average. Her average looks like 90 plus 88 plus 93 plus 85 plus that 5th test, which is her x, divided by 5. Okay, so what we need to do here, we've got a double inequality. In order to make a B, she's got to make an 80 on up to a 90, but not equal to a 90, because if she meets or makes a 90, she's actually made an A. Okay, so let's solve this double inequality. So this trick with double inequalities is what you do to one thing, you need to do to all 3. So I need to get rid of this 5 here. So if I want to get rid of that 5, I've got to multiply everything by 5. So what we get is 80 times 5 is 400, which is less than or equal to 90 plus 88 plus 93 plus 85 plus x which is less than 5 times 90 is 450, and that is a terrible looking greater than sign. So, or less than sign, however you want to look at it. So I'm going to erase it and put a better looking one on there for you. I know my handwriting's never that great, but I can do at least a little bit better. So this 5 canceled out this 5, which is why we don't have a denominator on a middle term. 5 times 80 was 400, 5 times 90 was 450. Okay, now what we need to do is you need to take your TI and you need to add up all those numbers in the middle and simplify that. So 90 plus 88 plus 93 plus 85 should give you 356. So I'm just going to simplify it here. 356 plus x. It's definitely a 6. Is less than 450. Oops. Is actually greater than or equal to 400. Okay, so what you need to do now is we need to get rid of this 356. So I need to subtract it off so that I can get x by itself. Now I subtract it off here, also got to subtract it off here, and I've got to subtract it off here. Okay, so I've subtracted it off all 3 pieces, this piece, the middle piece, and this piece, so that now I can simplify it. Now 400 minus 56 would be 44. That'll be less than or equal to x. That'll be less than, now let's see, 450 minus 356 I believe is 94. Is that right? I always like to double check myself there. Yeah, that's 94. So if she makes a 44 on up to a 94, she will make at least, or she will make a B. Okay, if she makes a 94, she'll actually make an A, but if she makes anything less than a 94 on down to a 44, she will make a B in the course. And that is how double inequalities work. Okay, so we got another example here. So in this example, we have 120 is less than 20x minus 40, which is less than or equal to 160. Okay, so what I'm going to do here is, the first thing I'm going to do is add 40 to all three sides so I can get my x piece by itself. So I'm going to add 40 here, I'm going to add 40 here, I'm going to add 40 here. Okay. This results in 120 plus 40 is 160, which is less than 20x, which is less than or equal to 160 plus 40 will be 200. Now I have to divide off that 20 so I can get x by itself, but I have to do it to all three pieces. So distribute it to all three pieces here, and what I find is that x, which goes in the middle, is greater than, now 160 divided by 20 should give you an 8, and 200 divided by 20 should give you a 10. So 8 is less than x is less than or equal to 10. Easy enough. Now example 2 here says 3x minus or plus 1 is less than 7, and 2x minus 5 is greater than 6. So let's solve this out, see what it looks like. Okay. Now and means they have to happen at the same time. Okay. So both of those have to be true at the same time. So let's get to solving. I'm going to solve the first one, then solve the second one, and then we'll work on that and piece. So obviously it's pretty simple. I'm going to subtract off a 1 here, so that I get 3x is less than 6. Divide by 3 so that x is less than 2. Okay. Alright, now here, for the other piece, I'm going to add 5. Oops. I'm going to add 5 so that 2x is greater than, let's see, 6 plus 5 is 11, so that x is greater than 11 over 2. Okay, so 11 over 2 is about the same thing as 5.5. Okay, so here, and means both of them have to happen. Okay, so x needs to be less than 2 and so x needs to be less than 2 and x needs to be greater than 11 over 2. Now sit there and think if that's possible. So I'm going to come over here and draw a number line. And it's not a very straight number line, but it's the best I can do. So we'll say 0 is here, negative 1 is here. 1, 2, 3, 4, 5, and 6. We'll even go 7 just to make it a little longer. Got us a number line here. So in green, I'm going to say, okay, x needs to be less than 2. Okay, it's less than, it's not less than or equal to, so I'll do an open circle. It needs to go this way. Okay, and in orange, I'll do this part. Okay, x needs to be greater than 11 over 2. 11 over 2, we said the same thing as 5.5. So greater than this, open circle because it's not equal to. So the and statement here, that's what's really important. So this and statement, that means both of them need to happen at the same time. Now the thing here is, okay, this needs to be true and this needs to be true. Well, if this one's going this way and this one's going this way, they're not true at the same time anywhere. So the actual answer here would be no solution. So it might pay off to make you a little sketch of a number line, and with and they have to happen at the same time. Okay, so there has to be some kind of intersection between the two. Here there's not. Let's look at example 3. Example 3 says 6x minus 2 is less than or equal to negative 5, or 3x plus 4 is greater than 9. Now this one has that or statement. That or statement means that either or could happen. So they don't have to happen at the same time, but at least one of the two has to be true at all times. Okay, so let's go through and solve each of them. Okay, so here I'm going to add 2 to both sides so that I get 6x less than equal to, now if I add 2 to negative 5, I get negative 3. If I divide by 6 and simplify, I get x is less than or equal to negative 1/2. If you need to take extra steps in order to get there, be my guest. But you should be getting pretty quick at solving these by hand and simplifying them without so many steps by now. Now let's solve this other side. So we'll solve this other side here in, I guess we will do it in brown. Okay, I'll subtract 4 off here, subtract 4 on this side, so that what I get is 3x is greater than 5. And I'll solve for x. I'll say x is greater than 5/3. Easy enough so far. It's an or statement here, okay? So if I look, oops, let's do it in black like we did last time so we can contrast the colors. Okay, so we've got our number line here. Let's go -2, -1, 0, 1, 2, 3, 4. Okay, so in blue, I'll do the x less than or equal to -1/2. So we'll go to -1/2. We will put us a solid circle because it is actually equal to. And it's less than that, so that means it's going to go this way. Okay. Now I'm going to do the other one, like I said, in brown, so I'll come over here. X is greater than 5/3. Now 5/3 is not quite 2, but it's pretty close. It's like 1 2/3. So it goes about right here. It's an open circle because it's not equal to, and x is greater than that. Oops, that is not a very straight line at all. So I can do a little bit better, I think. Pretty close, and it goes this direction. Okay, so this is what our graph looks like for us on a number line. Now it's an or statement, which means only one has to be true at a time. They can both be true at the same time, that's fine as well, but only one has to be true at one time or another. So what you would have here, you would actually have a solution here because it's an or statement, not an and statement. And if I wanted to write it, the way I could write it here, if you wanted to write it in interval notation, would be negative infinity to -1/2. And you'd have to have a bracket here because it's equal to. And then you could say that's unioned with, we've got parentheses here for 5/3 because it's not equal to, all the way to infinity. And infinities always have a parentheses rather than a bracket on them. So if you wanted to write it as a union of sets in interval notation, that's how you could write it. Or you could replace the union with or. Okay, that'd be fine as well. Depends on how my math lab asks you to input it. Alright, let's look at example 4. Example 4 says 16x minus 8 is greater than 12, and 16x minus 8 is less than 32. So let's look at this one. I'll solve the first one in orange. So if I add 8 to both sides, I get 16x is greater than 12 plus 8 is 20. You can divide by 16. If you divide by 16, you get x is greater than 20 over 16. You can then simplify that. They're both divisible by 4. And what you'll get is a 5 over 4. So x is greater than 5 over 4. Okay, so that's the first one. Now let's do the second one. The second one, once again, we'll add 8 to both sides. We get 16x is less than 40. Okay, we divide by 16, we get x is less than 40 over 16. Now your number that you got in common here between the 40 and the 16 would be your 8. So here, if I divide 40 by 8, I'm going to get a 5. If I divide 16 by 8, I'm going to get a 2. Okay, so that what I see here is that x has to be greater than 5 over 4, but less than 5 over 2. So let's look at our number line for that. Okay. So if I do a number line for this, I'll start with a 0 here, 1 here, 2, 3, and 4. I'll plot the first one in orange so it'll match. So x is greater than 5 over 4. Now 5 over 4 is the same thing as 1 1/4. So it's about, say right here, it's an open circle because it's not equal to. So x is greater than this. So it goes on like this. Okay. Now for the other piece I need to graph it as well. X is less than 5 over 2. So 5 over 2 is the same thing as about 4 1/2. So I should have extended my number line here to include that, shouldn't I? So 5 over 4, no, that's not right. Why you let me say that? 5 over 2 is not the same thing as 4 1/2. Sorry. 5 over 2 is the same thing as, that's going to be, what, 2 1/2. Yeah, 2 1/2, because 4 divided by 2 is 2. And you got that extra half left over, so 2 1/2. I knew I had something wrong. So 2 1/2 is about here, and it's less than that. It's an open circle because it's not equal to. So what you get is something that looks like this. This piece right here says that it goes from here and goes left. This piece here says it goes from here and goes right. Now, what does that mean? It's an AND statement. So because it's an AND statement, they both have to be correct at the same time, which means that I can't have only one be correct. They both have to be correct, which means that they need to exist both at the same time, which means that exactly what we're looking at here is only where both lines exist. So between here and here. So that what I'm really looking at here is my answer, if you wanted to write it in interval notation, would be that it would go from 5 over 4 with a parentheses to 5 over 2 with the parentheses, not being equal on either side because both aren't equal on both sides at that point. And that will be your answer for that one in interval notation. Okay. Now if you wanted to rewrite it in with your signs and stuff here, the way you would have to do it for it is you could write it with the and. You could say x is greater than 5 over 4 and x is less than 5 over 2. But if you wanted to write it as, say, like a double inequality, so to speak, you would have to say that 5 over 4 is less than x is less than 5 over 2. Okay. Now you can't always, you got to be careful with these because you can't always manipulate these back into these style statements here, but sometimes you can. Let's look at example 5. Example 5 says it's a double inequality. We've got 17 less than or equal to negative 3x minus 5, which is less than 31. So let's go ahead and add this 5 and get it out the way. So we got to add it to all three pieces, the inside and both outsides. We've got 17 plus 5. So 17 plus 5 is going to wind up giving us a 22, which is less than or equal to 3x, which is less than 36. And don't forget your negative on your 3x. Okay, very important. Now, here's something we hadn't hit yet, but that hopefully you already know. Here we're going to divide by negative 3 on all three sides. That is something you should know. Okay. And when you do that, what winds up happening is your sign switch. Okay. So they're going to switch directions. So what we get is 22 over negative 3 is greater than or equal to x, which is greater than, now 36 divided by negative 3 should give you a negative 12. Alright, so we definitely want to simplify if we can, which is why we simplified 36 divided by that negative 3 here to 12. We can't exactly simplify here. This 22 over negative 3 doesn't really simplify. But we need to make sure this makes sense. Okay? Because sometimes when you divide by these negatives, it turns it into a statement that doesn't make sense. And maybe it didn't make sense to begin with in the first place. But if I'm looking at this, okay, and you can draw it on a number line if you want to. And sometimes it even helps to go ahead and rewrite it in a different direction. And what I mean by that is negative 12 is less than x is less than or equal to 22 over 3. Okay, now 22 over 3, if we're looking at that, that'll wind up being, and it's negative as well. Don't forget your negatives when you switch stuff around. But negative 22 over 3, if we're looking at it, it's approximately 7, approximately the same thing. I better write that in another color. In. So this is the same thing as negative 7 and 1/3. Okay, to kind of give you a better idea. Okay, and the reason I like writing it this way is because your smaller number comes first and your bigger number comes second. But it is entirely possible that x can live between these two numbers. So that's really the only thing you want to kind of double check, and that's the reason I wrote it as negative 7 1/3 rather than negative 22 over 3, because it can be kind of hard to compare those just with the eye test. It's a little easier to compare and say, okay, negative 12 is much more or much smaller than negative 7 1/3. Okay, so this works out. This will be your answer. If you wanted to write it in interval notation, you could simply do parentheses negative 12 because it's not equal to, comma, negative 22 over 3 bracket, because it's an equal to sign right there. That's then equal to. Alright, moving on to page 3. And I believe we got, what, is it 2 or 3? 3 more examples left on page 3. So, word problems. Everybody loves word problems, right? Example 6 says Deb Cook is given the choice of two positions, one paying $3,100 per month and the other paying $2,000 per month plus a 5% commission on all sales made during the month. What amount must she sell in a month for her second position to be more profitable? Okay, so second position more profitable than the first. Well, the first position, getting worse with my hand right now in a class. The first position pays out $3,100 per month. In order for the second position to be more profitable, that $2,000 plus that 5% commission, which we need to change to a decimal, so 0.05%, times however much she sells X. That's what needs to be greater than 3,100. Okay, so let's figure out what amount she must sell in a month in order for this second position to be more profitable. Let's just solve for X here. So what I'm going to do, start out with, I'm going to subtract off that 2,000 from both sides. Man, these little pins are rough. Okay, so 3,100 minus 2,000 is going to wind up giving you a 1,100. And that's going to be less than 0.05x. Now obviously what we're going to need to do next is divide by that 0.05 on both sides. The only time you switch the sign is when you're dividing by a negative. Let me say that while I'm writing this up too. So we're not dividing by a negative. We don't have to switch the signs. So I'm going to bring it over here, change colors once again. X has to be greater than. So you can take a TI real quick. And if I can find mine sitting right next to me, we can divide this out real quick. 1,100 divided by 0.05 equals 22,000. So, in order for the second job to pay more, she must sell more than $22,000 in whatever she's selling. Doesn't say what she's selling necessarily in the position, but she needs to sell more than $22,000 of it each month in order to make more at the second job. Okay, so depending on what the job is, that might be really easy, might be really hard. If she's selling staplers at Staples, it's probably going to be pretty difficult. If she's selling cars at a new car lot, that shouldn't be that hard at all, because a brand new car pretty much is going to run you that, and as long as she makes one sale per month, she will be making way more at the second job. But that'll be something for her to compare. Now let's look at example 7. It says the percent of the U.S. population with internet access can be modeled by y equals 1.36x plus 68.8 with x equal to the number of years after 2000. When does this model indicate the U.S. population with internet access exceeds 89%? Okay, so what we're looking at here is when will it exceed 89%? So we don't need to change that percent to a decimal because y is the percent. So it needs to exceed it, not equal it. So 89 needs to be less than 1.36x plus 68.8. Okay, so oops, left my x off here. Don't do that. Alright, now we just have to solve for x. So we'll subtract off 68.8. Alright, so 89 minus 68.8. You can use your calculator to find that. Should give you 20.2. That is less than 1.36x. Okay, then obviously I need to divide by 1.36 on both sides. So that our final answer looks like x needs to be greater than, now 20.2 divided by 1.36 is 14.2. 14.85. Okay, now let's look at the context of the problem and try to give it an answer that actually makes sense. So it says X equals the number of years after 2000. When does the model indicate the U.S. population with internet access will exceed 89%? So let's round to the nearest whole number so we can talk about a whole year. So we'll round to 15. So in year 15 is really when it's going to hit it. Okay, so in what, let's say, okay, the year, when, so from 2015 and further, it should have internet access of more than 89%. So that's how you would answer that. Okay, because if you input the 14.85 even just the 15, if you inputted 15, that wouldn't be the answer it was looking for. It's not also wouldn't be looking for, you know, the 15 comma infinity. The reason it tells you the number of years after 2000 right here in the problem is so that you can know that you need to, okay, take that 15, add it to that 2000. So be careful on how the question is written up so that when you respond to it, you respond correctly. Sometimes you got to look through and kind of read through the part of the word problem and figure out exactly what they're looking for. Now I got one more example, example 8. Example 8 says the yearly profit from the production and sale of plumber's help is P of X equals negative 40,255 plus 9.80x dollars, where X is the number of plumber's helps produced and sold. What level of production and sales will result in a loss? Okay, so we're looking at the yearly profit from production and the sale. Okay, so this is your profit function here. Okay, so what level of sales will result in a loss? Okay, so a loss, if we're thinking about it, we've got our production value here, P of X, or our profit from production value here, P of X. In order for it to result in a loss, you're going to technically have to be less than 0, right? So if you're losing money or your profit's in the negative, then you're not making a profit, you're actually losing. Okay, so essentially what we're going to do here is we're going to do negative 40,255 plus $9.80 times X is less than 0 because we're resulting in a loss here. So what we're going to do, we're going to add this 40,255 to both sides. Okay, so when we do that, we get 9.8. I'm going to leave off the 0. You can put it on there if you want to. X is less than 40,255. If you want to put the comma in there, you can do that as well. So obviously what we need to do next is divide by that 9.8. Okay. So that when X is less than, and you can use your calculator here because that's what I'm about to do. So let's put this one up, 40,255 divided by 9.8 should give you 4,107.6. X is the number of plumber's helpers produced and sold, so I'm going to go ahead and round it up to 4,108 because, like I said, they're not going to produce a piece of a unit, they're going to produce a whole number or whole unit, so that essentially, if they produce less than 4,108 units, they are not going to make a profit. They're going to make a loss. The break even would be that 4,107.65306. That's what I got on my calculator. Hopefully that's what you got on yours. Obviously, like I said, they're not going to make that piece of a unit. So if they actually make 4,108 units, they'll actually make a very small profit. So that's kind of how your answer flows there. And if it asks you to give exact or to round to 2 decimal places, be sure to do that on your MyMathLab or whatever here. I'm just trying to make it make a little bit of sense with this problem because it didn't tell us how to round. Okay, so what level of production and sales will result in a loss? So anything less than 4,108 numbers produced and sold. So that's how that problem would go. That pretty much finishes up chapter 2. So this is the end of chapter 2, which means you are due for your very first test. So since you're due for your first test, make sure you take some time to study, go back and review everything from chapter 1 and chapter 2. If you need to review your homework or go back and see what you missed on your homework, so you get back right with it, please take all opportunity to do that. If you have any questions, let me know. Go ahead and try to access your test early because you only have a certain amount of time to do it in, and if you wait till an hour before it's due and have technical issues, there's a good chance I'm not going to be available to help you because I think it could be very late at night or whatever. So give yourself a buffer time. If it opens, when it opens, go ahead and plan to do it early. That way, if you have technical issues, you can get in touch with me and we can get those resolved before the test expires. Because I don't like extending tests, and I hardly ever do it unless you have a valid excuse. And technological issues an hour before it's due doesn't really qualify as a valid excuse. So anyway, like I said, go back, review, make sure you're ready so we can get you a good grade on this test 1. That way the rest of the semester will flow very, very nicely. If you have any questions, let me know. As always, I'm available by email, and I appreciate you watching. I'll see you in chapter 3.